Hi, I'm Michael Ling, CEO of Jinbao Systems. Today, it's my pleasure to present our SkinnyTube technology and products. The current swab transport media tube was based on a chemist's test tube, simply repurposed for this application. It was not rationally designed for collecting and testing swab samples for the detection of pathogens causing infections. The main problem is the current swab transport media tube dilutes samples too much, leading to missed detection of pathogens. Because the swab is immersed in 2 to 3 mL of liquid, while only 1/10 of that liquid is typically required for testing. This seemingly innocuous dilution could be the difference between detecting and or not detecting a person with COVID-19. Introducing the SkinnyTube, a Canadian invention. As shown in the picture in the middle of the slide, the SkinnyTube features a smaller volume medium fill, resulting in less dilution compared to the regular swab transport media tube. In addition, the tube-in-tube design provides better protection. Even when the tube is laid on its side, the swab will remain immersed, which is critical to ensure a valid test result can be obtained from the sample. Let's examine how the SkinnyTube helps improving testing. Here is a set of SARS-CoV-2 viral samples with increasing concentrations, collected in regular swab transport media tubes. For SARS-CoV-2 testing, the best PCR tests detect the virus at around 100 copies per ml or higher. So these screen samples are detected. When we use SkinnyTube to collect the samples, all these samples are presented in tenfold higher concentration, assuming that the contrast between the tubes are 0.3 mL versus 3 mL. This means we can detect the viruses 3 doublings earlier or many hours earlier in the viral infection cycle using exactly the same downstream PCR test. As a proof of principle experiment for the SkinnyTube, we tested 18 SARS-CoV-2 viral sample replicates in a study performed in conjunction with McMaster University. Identical samples were collected into 2 sets of regular swab transport media tube and a SkinnyTube. 2 SARS-CoV-2 PCR assays were performed. The results showed in this slide were as expected. We observed a lower CT value for the SkinnyTube group compared to the regular group, on average 3.3 lower CT. That's equivalent to tenfold higher concentration. In the second assay, we observed a better detection rate, going from 72% for the regular tube group to 100% detection in the SkinnyTube group. The SkinnyTube supported better detection of the virus in this study. Adopting the SkinnyTube is easy. The SkinnyTube fits directly into the existing procedures and the protocol. The same sample collection procedure, the RNA extraction procedure using SARS-CoV-2 as an example here, and the PCR testing protocols can be followed. We just need to change the regular tube to the SkinnyTube. Finally, this technology can benefit all tests utilizing swabs as a specimen type. We encourage you to consider adopting the SkinnyTube technology. Thank you. To see how the SkinnyTube is used exactly as the regular tube in collecting and testing swab samples, please watch this video linked below. Thank you.